Okay, this is Unit 8, Day 1, and this is part of the notes we're going to do this day, and this has got a lot of review stuff. Notice we have formulas for midpoint, distance, and slope up here, and we've used all those formulas before this year, and those are actually all from algebra. So we've just got these up here to review over these as we go. Step 1 says graph and label these points, and I've already graphed them and I connected them and they make a triangle there. Then it says find the midpoint of the following segments. Well, we gave you one that's pretty easy to do, and if the segment is going vertical or horizontal, it's really easy to find the middle. We can just say, well, this segment here is 1, 2, 3, 4, 5, 6 boxes tall. So if it's 6 tall, then the middle has got to be 3 up. So the middle is right here. And I'm going to put a little circle right there at the middle of it. So I'm going to also label my points. P, Q, R. I just labeled them from here. So the middle of PQ is right here, and they want me to label it as S, and it's at point -4, 1. The middle of QR, that's this one here, well, this one is 8 units long, so the middle is going to be right here, and they want me to label that one as T. And this one is at, remember, you go across, this is the X and this is the Y, so this one is going across 0 and then down 2. So this is 0, -2. And it should make sense because Q and R are here and here. What's going to be the middle of that? Well, it's got to be, this has got to be 0 to be between these two and -2 to be between that. And finally, this one is the slanted one that's possibly a little harder to find. I'm going to quickly remind you of how to use the midpoint formula. It's just the average. We take the two x values, so PR, that's this one and this one. We take the two x values, -4 and 4. We add them together and we divide by 2. Well, -4 plus 4 is 0, over 2 is 0. And I'm going to do the same thing with the y's. Here's the y's. 4 plus -2 over 2. 4 plus -2, that's 2 over 2. And that gives me 1. Let's see where that puts our point. It puts it at 0 and 1 right there. And if you look at this, this does in fact look like it's in the middle. So I use the formula just to remind you how that formula up there works, and it's at 0, 1, and we're going to label that U. Then it says, then graph these and label them, and connect them to form a triangle. So I went ahead and connected those three to make another little triangle there. So now it says find the length of each one of these sides we have here. Again, if it's going vertical or horizontal, it's real easy. PQ, we already talked about, we counted that up, that was 6. QR, that's going across, we counted that up, that's 8. UT, that's this one here, it's vertical again, so I can just count it, it's 3. And US, that's this one here, it's horizontal, it's 4. Now, PR is this one here. I can use the distance formula like we did earlier, or I can just use Pythagorean theorem. Pythagorean theorem, remember, is a squared plus b squared equals c squared. This side was 6. This side was 8. We just wrote them down here. This side was 8. And I want to find the slanted side. This is 36 plus 64 equals c squared. 100 equals c squared. Take the square root of that on your calculator, and you get that this side here is 10 long. If you did it with the Pythagorean theorem, if you do it with the distance formula, it's exactly the same steps that we did here. So this side is 10, and we can do the exact same thing to find ST, this one here. A squared plus b squared equals c squared. This side is 3, this side is 4. This is 9 plus 16. That's 25. Take the square root, and we get this side is 5. Now, what does it says down here? The reason we were doing that is it says, what do you notice about the measures of these segments? Well, when I compared the purple ones with the green ones on each one of these, what do you notice about all the purple ones compared to all the green ones? Well, the smaller ones are half of the big ones. They're exactly half each time. That's a very useful thing to know, that every time when I connect two of these, it's exactly half the length of the bottom there. Okay, now let's flip over, and we're going to find the slope of each one of the segments. So we're going to find the slope of all of these again. Well, PQ, if you remember, vertical slopes like this, have no slope. Horizontal ones like this have 0 slope. And ones slanted like this are rise over run. So, the ones PQ and UT have no slope. PQ and UT, those are no slope. The horizontal ones, QR and SU, have 0 slope. And PR, this purple one, is rise -6, run 8. Rise over run is -6 over 8, which reduces to -3/4. Now let's look at ST. ST is rise -3 over run 4. So rise -3 over run 4. What do you notice about the slopes of the purple ones versus the green ones? They have the same slope. So now it says find the perimeter of each one of these triangles. Well, we can find the perimeter by just adding these up. This is the purple one. So if I add this up, 6 plus 8 plus 10, we get 24. STU, that's this one right here, 3, 4, 5. Let's add that up. That adds up to be 12. What do we notice about this? The smaller triangle is half the big one. So what we call all these segments, which I didn't start off by pointing out, is when I connect the middle of this side with the middle of that side, we call that a mid-segment. Mid, the middle, right? If I connect those, it's the mid-segment. And we figured out several important rules about mid-segments. So if it's a mid-segment, it connects the middle of two sides, connects the midpoint of two sides, and its measure, its length, is half the measure of its parallel side. So if I connect these two, this one is parallel to that one, and this is half that length. If I connect these two, this one is parallel to this one, and this one's half this length. This one, it's parallel to that one, and it's half its length. So two things, parallel and half the length.